We are ready. Go.
Hello,
okay,
everyone.
So I won't be providing descriptors, so what I'll do is just give a quick countdown for you all, then I'll be stopping the music, okay? So in 3, 2, 1.
All right. Hello, everyone. I'm Nancy Neal Jones from the Office of Communications at NASA Goddard Space Flight Center. I'm standing in the mission support area at Lockheed Martin Space Facility. We are complying with local county guidelines and Lockheed Martin's social distancing policy of maintaining at least 6 feet when possible and by wearing masks. Yesterday, NASA's first asteroid sample return mission, OSIRIS-REx, successfully made contact with the surface of asteroid Bennu to collect a pristine sample for delivery to Earth in 2023. To share some remarks with us and to tell us more about what happened yesterday and what's coming up for the mission, we have with us today Jim Bridenstine, NASA Administrator, NASA Headquarters, who'll be joining us by phone. Thomas Zabukin, Associate Administrator, Science Mission Directorate, NASA Headquarters. He will also be joining us by phone. Dante Loretta, OSIRIS-REx Principal Investigator, University of Arizona. Rich Burns, OSIRIS-REx Project Manager, NASA's Goddard Space Flight Center. And Sandy Friend, OSIRIS-REx Mission Operations Manager, Lockheed Martin Space. We'll start with the Administrator, with Administrator Bridenstine joining us from his phone. Administrator Bridenstine, we turn it over to you.
Well, thank you. It's an amazing day. I just saw the first images there of OSIRIS-REx touching down on Bennu, and it was every bit as beautiful as I thought it would be. What an amazing accomplishment by such amazing people at this time. We think about the challenges of getting OSIRIS-REx built and launched. We think about, this has been a project that NASA and the University of Arizona and Lockheed Martin and all of our partners, we've been collaborating on since 2011. And I know University of Arizona was working on it even before that, trying to get it approved. And here we are in the year 2020 with this really stunning achievement. And I just want to say congratulations to all of the teams. The idea that this team broke the record for being able to orbit the smallest object that's ever been orbited before, the idea that they were able to orbit an object closer than any object has ever been orbited before, the idea that when we got there, we learned so much about how rough the terrain was, which was not anticipated, how small of a landing area we actually had, and then ultimately being able to use this extremely sophisticated precision navigation capability that way outperformed what anybody believed could be done. Of course, I know the people who built it believed in it 100%. But it was just, it was an amazing day yesterday when we watched it land in a parking spot. Basically, the area was about the size of 2 parking spaces side by side, and it landed just as it should have. We didn't get 5 or 10 seconds on the surface. We got 15 seconds. And of course, we're going to be learning more about how much sample we got and things like that. But it went as well as could have gone. I said it yesterday. I'll say it again. The OSIRIS-REx mission outperformed in every way. And so I just wanted to make sure that I congratulated the teams. And you guys all made not just the United States of America proud, but you made humanity proud in your ability to go way out into deep space and characterize this asteroid Bennu. There's so much more to do. I want to be clear, there's a lot left to do. We've got to bring the sample home. But at the same time, this in itself, the touchdown, the sample collection, was an amazing achievement, and I want to congratulate the team. So with that, I'll turn it back over.
Thank you, sir. Thanks, Administrator. It's Thomas Zabukin here, and yes, yesterday our team did an amazing thing, a true first for NASA. The mission, of course, had its genesis in the early 2000s, like you said, and OREX finally had the penultimate act of its amazing journey when it successfully touched the surface of Bennu to collect a sample. We're going to hear about this, but everything finally went like it should and like we hoped yesterday. The technology performed flawlessly, and the commands our great team sent to the spacecraft unfolded autonomously. Since the signal from the Earth to OSIRIS-REx is 18 plus minutes, and the spacecraft had to be preloaded and prepared for this amazing journey on its own. I remember thinking on multiple occasions, Dante, yesterday, and Rich, wow, if only the speed of light was a lot faster. And it isn't, of course. The spacecraft slowly approached the surface of Bennu. Its data getting more detailed, and the risk going down, decreasing as we got more and more information and approaching that target with an accuracy unprecedented in previous tests. It then touched Bennu, and we're going to hear about this, brushed into the regolith and stirred up a swirl of material, probably unlike anything Bennu had seen in quite a while. And then, as planned, evaluating its surrounding, the spacecraft backed away and is talking to its handlers on Earth. The team has a lot to work on to analyze, and which is likely to be a sample, and it appears that the spacecraft is safe. And again, I look forward to hearing the details here. This is all the beginning of the process, and we're nowhere near the end. This morning, in fact, I thought of the analogy of fishing. Yes, the line tightened and the sinker dropped, and we are excited, but now we need to bring it in, see whether we caught the fish, and then, of course, bring it home. It was an honor and a joy to be with the mission control team yesterday and the leadership team at Lockheed, and we determined that the spacecraft had done exactly what it was designed for, and apparently touched the surface and fired the gas bottle, powers the collection mechanism, the TAXAM, and is now safely on its way back from this hazardous environment. It's always an amazing feeling to be with people celebrating such a success for humanity, as the administrator said, one that took many thousands of people over many years to achieve. I know from my emails and text streams and social media that scientists within the United States and around the world are ecstatic. Discoveries we will make about our solar system and our planet from materials that was around at the time of its formation will be immense. And the questions that we have, whether or not these bodies could in fact seed life on Earth, is another tantalizing avenue we want to pursue, and many more. And it looks like many generations will have the chance to pursue these kind of questions and others from the pristine samples coming back to Earth. And countless discoveries and researches will be happening as a result of that. So Dante, Loretta, principal investigator, I want to commend you and the entire team at the University of Arizona, the team at NASA Goddard and Rich Burns and others, and Lockheed Martin, with the good people that we met there yesterday. I also want to give a shout out again to our international partners on OSIRIS-REx, the Canadian Space Agency and the Japanese Space Agency, who are our partners in asteroid exploration. And I really look forward with everyone else to hear from Dante and the team about the details of how we pulled off this incredible mission and what's next. Most importantly, I really look forward to him releasing what I believe will become an iconic image of the power and excitement of exploration, one that inspires all of us. Back to you.
Okay, thank you. Thank you, Administrator Bridenstine and Dr. Zabukin. We will now turn it over to Dante Loretta, the principal investigator of the OSIRIS-REx mission. Dante?
Thank you, Nancy, and thank you, Administrator Bridenstine and Dr. Zabukin, for your words of support and encouragement. It was great to have Dr. Zabukin and Dr. Lori Glaze and other representatives from headquarters here yesterday supporting and encouraging this team, and we really appreciated Administrator Bridenstine's congratulations to the entire team yesterday. It uplifted the team to an even higher level after an amazing accomplishment, and we really appreciate you joining the team in our celebration. So yesterday was all about monitoring this real-time telemetry from the spacecraft as we watched the events unfold 200 million miles away. And the question that came up over and over again in that live broadcast was, when are we going to get the images back? When are we going to know how the sampling event went? I can tell you, a lot of us were up really late last night. We were watching the images come down one by one. By about 2 a.m. here, local time in Denver, we got what I call the money shot, where we saw tag sand contacting the surface and then the effect of injecting that high purity gas down into the asteroid regolith. So I think without further ado, let's just go and take a quick look at the data. I'm going to show you a series of images taken by the SamCam. This is about twice the frame rate, so we're coming in a little bit faster here. And I'm just going to let that play out. I'm going to let you appreciate it one more time as we go through. And then we've got some analysis that we can perform about what happened here. Maybe one more time. It's just so cool. I must have watched it about 100 times last night before I finally got a little bit of shut-eye. And then I dreamed of a wonder world of Bennu regolith particles floating all around me. So just to remind you what we're looking at here, this is a full-scale model of the TAGSAM head. And so this is what's at the end of that long robotic arm. You can see it's about 30 centimeters or about a foot in diameter. And this is what we placed onto the surface of the asteroid. It's at the end of the robotic arm, and the high-purity nitrogen gas feeds in here through a couple tubes, and then it actually comes out through this inner annulus and pushes everything up into the collection chamber. Let's take another look at just a couple of the key images right before contact and right after contact before the gas is fired. So there's a little over 1 second time difference between these two images. And there's an enormous wealth of information about the asteroid surface contained in here. So the first thing that you can see, if you look at the area right above about the 12 o'clock position on the sample head, we're making contact with a relatively large rock, a little over 20 centimeters, which we had considered a potential obstruction to sampling. But literally, we crushed it. When the spacecraft made contact, that rock appears to fragment and shatter, which is great news because that means that ingestible material by TAGSAM is probably being created just by the motion of the spacecraft pushing into the surface. If you look at a couple other areas around, like this one here about 1030, just off to the upper left of the TAGSAM head, you can actually see motion in the regolith. So it looks like we are pushing and exerting a force throughout this soil on the asteroid surface. Also good news for our potential for successful sample collection. I want to point out another feature of the TAGSAM head that didn't get a lot of attention yesterday. We talked a lot about the gas stimulation and driving bulk sample into this filter. But as you can see in this 3D printed model of TAGSAM, there's a whole series of circular discs. On the flight hardware, what's mounted in here are contact pads, literally made out of stainless steel Velcro. And these are designed to pick up material on the order of a millimeter size and smaller. So the fact that when the TAGSAM head is making contact with the asteroid surface and it's crushing what appears to be a very soft, friable material is good news not only for the bulk sample collection, because in our laboratory tests, when the TAGSAM head penetrates, and we're estimating about 2 centimeters of penetration at least during this event, a lot of material gets forced up into the sample collector. And of course, by crushing, you're going to drive a lot of material into these contact pads. So right away, bottom line is, from analysis of the images that we've gotten down so far, is that the sampling event went really well, as good as we could have imagined it would. And I think the chances that there's material inside the TAGSAM head have gone way up based on the analysis of these images. We're going to take a look at just one more sequence now after the event when the gas bottle gets fired. You can see that particles are flying all over the place. We really did kind of make a mess on the surface of this asteroid, but it's a good mess. It's the kind of mess we were hoping for. Lots of material has been mobilized, giving us additional confidence that we actually pushed material up into the sampler head. And just a little bit of the timeline here. We made contact. About 1 second went by. The gas bottle fired. The gas was blown down for about 5 seconds, which is as much time as we were hoping to get to collect that material. So the system seems to have performed nominally. The surface of Bennu behaved very well. And so everything that we can see from these initial images indicates sampling success. We still have some work to do. We're going to go through our entire procedure, including what we'll hear from Sandy later in the day about the additional activities for sample verification. So in case you can't tell, I'm pretty excited about all of this. This is great news, and I'm going to turn it over to Rich to talk about the spacecraft performance from here.
Thanks very much, Dante. Happy to be here. We're all super excited to be sharing all this information with you, and I'm going to try to set some context for the movie that Dante showed, with showing you exactly what happened during the last stages of TAG. and orienting you with what our sample site Nightingale looked like. So let's begin with the animation. This is the final descent stages. This is the same perspective you see in the images. This is an animation, of course. So we'll transfer to a perspective that's near the surface, so you see just how rugged the terrain is here. And then at contact, you'll see the sample collection head make contact with the surface. Regolith gets disturbed, and then the nitrogen bottle gets fired, and more regolith get disturbed. The cutaway of the sample collection head shows the airflow of the nitrogen and the back away maneuver from the surface. So that completes. That maneuver completed the sequence, and we're safely away from the surface right now. I'll turn now to orientation of the sample collection site Nightingale, and we'll show a graphic to describe that. So you see on the upper right is an image from our reconnaissance C. The resolution in that image is about 4 millimeters per pixel. The yellow circle in that image is the dimension of our sample collection head. So it gives you a sense of the rocks, the material that was under the collection head at the time of contact. And then the bottom right is just the snapshot of the sample collection head just before contact. On the left-hand side of this graphic is the Nightingale site. And annotated on that graphic is our estimated point of contact, which is less than a meter away from the center of the site. I'll emphasize that because we're over 320 million kilometers away from Earth at this point, and we touched this asteroid within a meter of where we intended to. So that's extraordinary, and a real credit to our team, our navigators, the folks here at Lockheed, and the science team, who all had to come together to enable that to happen, to allow the navigation system to work, as Administrator Bridenstine said, outperforming our requirements. Our initial requirements were to land within 25 meters of a specified site. We landed within a meter. So incredible there. And also the rugged terrain you saw from the perspective near the surface of the site. Extraordinarily rugged terrain. The sample site Nightingale is actually one of the smoother areas, but quite small compared to that 25-meter requirement. Now we'll talk a little bit about where the spacecraft is presently. We'll start an animation that begins with the back-away maneuver. You see the thrusters firing. This is a 40 centimeter per second maneuver, which may not sound like much, but you see the spacecraft going away quickly from Bennu and out of orbit. This graphic shows the orbit we left from, and then we're on a hyperbolic trajectory, safely drifting away from Bennu. We will actually arrest that drift away on Friday at about 80 kilometers distance from Bennu. So all the mess that Dante described that we made, we're safely away from all that debris field at the present moment. And I'm going to turn it over to my colleague Sandy Friend from Lockheed.
All right, thank you, Rich. I'm going to talk a little bit about the spacecraft performance yesterday and what is coming up. So the spacecraft performance was phenomenal all throughout the TAG event, performing just as planned. Natural feature tracking, matching all of its features as we slowly descended. You've heard and seen from the images that we made contact, fired the gas bottle just as planned, and we hope to have a lot of regolith captured in there before we backed away. We did start downlinking our TAG data yesterday. We were fortunate to maintain communication throughout the contact and our 40-bit telemetry. Last night we were able to go to a higher data rate and get down some of our recorded data, including that phenomenal set of images that Dante just showed. All of our spacecraft subsystems are reporting nominal performance at this time. We're not working any issues. We did see a number of additional bright objects in our star tracker, not unexpected, seeing what came off the surface of Bennu, and that has all now cleared. So coming up, we have a series of spacecraft activities that's going to help inform us on how much sample we've collected and give us a little more insight into the spacecraft subsystems. Our first event will actually happen tomorrow, and we've got an animation showing what sample imaging looks like. So we're able to articulate our arm and the tag SAM head over our SAM cam, which will take a series of images. We are hoping that we can see lots of sample entrained inside the sampler head. We'll also be able to see evidence of sample on those contact pads, any dust that may be on the arm or the sampler head. So that'll be the first activity to help us determine just how much sample we've collected. Then our second activity is our sample mass measurement, and we have a second animation showing that. We'll extend the arm and spin the spacecraft. Now we've done this activity before, so we've got a pre-tag, and this will be our post-tag. That way we can compare the moment of inertia, which will help us determine how much mass is actually in the sampler head. We do also have a spacecraft checkout planned early next week, where we'll get an opportunity to do some engineering checkouts of some of our redundant components as we continue to trend the spacecraft, which looks just absolutely amazing after what we put it through yesterday. I'm going to turn it back over to Nancy.
Okay, thank you, Sandy. We're now ready to take questions from the media by phone. Operator, please patch through our first question.
Thank you. We will now begin the question and answer session. If you would like to ask a question, please press star 1, unmute your phone, and record your name. Your name and your associated press is required to introduce your question. To withdraw your question, please press star 2. Again, to ask a question, please press star 1. The first question comes from Marsha Dunn from Associated Press. Your line is open.
Congratulations. I heard Mr. Bridenstine say that contact was actually 15 seconds, which is a little longer than anticipated. I guess that's a good thing, right? And when do you think might be the soonest that you can declare success and have at least a pretty good hunch that you got what you were going after? Thank you.
Great question. I'll tell you, the 15 seconds I got in open media reports, so I'll let probably the experts tell us exactly what they know occurred. If Dante, if you'd like to take that.
I think I'll let Sandy answer that. She's our spacecraft engineer and analyze the telemetry that gives us that information.
Yeah, so our preliminary analysis of the telemetry shows that we were in contact with the surface for about 6 seconds, and our collection time about 5 seconds. It takes just about a second after we make contact before that gas bottle is fired, which is that 1 second difference.
So I read an article and it said 15, so I guess I was wrong. Marsha, I apologize.
Oh, that's quite all right. And when do you think the soonest might be that you'll have, if not an exact measurement, a pretty good idea that you that you can that the pressure might be down?
Yeah. So we're continuing. Oh, go ahead.
I just was going to say I'll defer.
Oh. Yeah, so we're continuing to analyze all the engineering data that we have on the ground so that we can better correlate all the data sets together and get an exact timeline of everything that happened here on the surface, how fast the bottle pressure went down, and all of that is being looked at very closely here as we look to analyze the sample we've collected. So hoping to have good solid timelines here in the next few days.
And I think the sample mass measurement is planned for Saturday.
Yes.
That's when the spacecraft will execute that maneuver, and the team needs some time to analyze that information. And so, Sandy, remind me, when do we expect the final report from GN&C on that value?
Yes, we are expecting a final sample mass measurement report on Monday.
Thank you.
Operator, we're ready for the next question.
Thank you. Tariq Malik of space.com, your line is open.
Hello. Thank you so much for the update here, and congratulations, it appears, so far on the sampling. My question is for Dante. I'm just curious. It's been a long road reaching Bennu with OSIRIS-REx, and very unexpected circumstances to try to actually collect samples of the asteroid last night. And I'm wondering kind of what you and the team are feeling or were feeling when you saw those images come down after, making lots of precautions for, the ongoing pandemic or, every other challenging situation that we're facing right now. I'm just curious kind of what that tone was like when you saw those images there?
Of course, that's a great question. So we stayed here at the MSA at Lockheed Martin fairly late last night. I stuck around to get to the point where we made the high gain antenna contact with the spacecraft, and we started to get the initial telemetry back down. And we actually had a spacecraft status meeting about 9:30 p.m. here, local Denver time. I got back to my apartment here in Denver around 11 o'clock last night, and I couldn't sleep. As you could imagine, I knew we were expecting those images around 2 a.m., so I got on to the chat. We have a chat feature with our science team, and the images get processed through the Science Processing and Operations Center in Tucson, Arizona. So our imaging scientists at U of A were busy downloading and analyzing the images, and the science team was analyzing them in real time through the chat feature. And we were producing the animated GIFs, looking at various aspects and timing in the sequences. And as you can imagine, the chat was filled with emojis and wows and all kinds of celebratory remarks. Science never sleeps in these kinds of conditions, so we immediately started assessing how far the TAGSAM head penetrated into the surface. Overall, the mood was jubilant because everything looked better than we expected. And I could say the best piece of information we got was that TAGSAM head looks like it pushed down into the asteroid surface. With all the laboratory testing that the team at Lockheed Martin did here to assess TAGSAM performance, some of the best test results occurred when TAGSAM gets down underneath the surface just a little bit and is able to fire the nitrogen gas with regolith all around it. So I know we're going to hear at another event later today from our TAGSAM scientist, Bo Bierhaus, so you can look forward to that. I know he is literally over the asteroid at this point with excitement about how his device has performed, and that spread throughout the entire science team. The only thing I'm looking forward to is maybe being able to sleep tonight knowing that we had a job really well done.
Thank you, Dante. Operator, next question.
Thank you. Stephen Clark of Space Flight Now, your line is open.
Hi, congratulations on the success. My question is for Dante. Are you at any point in the next few days or few weeks expecting to get any images inside the TAGSAM to see maybe an image of the sample that you collected? And I was wondering also if you have any estimate of the error bars that you'll have on your mass estimate from the spin maneuver this weekend. Thanks.
Yeah, thank you, Stephen. Absolutely. So I think the next major flight activity for the spacecraft is using the SAMCAM to image the TAGSAM head. Sandy showed an animation of what that sequence looks like just a little bit earlier. We will be able to look at the base plate. We'll be able to look at those contact pads. Based on what I've seen so far with the asteroid surface crushing underneath the TAGSAM head, I'm anticipating that we see contact pads coated in dark black asteroid regolith. But of course, we need those images down to verify that. We hope to be able to see inside the TAGSAM head, but that's not guaranteed. For one thing, the TAGSAM head may be so full of regolith that no light is able to penetrate inside that. I'm going to take that as a win. But it does require just the right lighting conditions for us to see inside that TAGSAM head, and we don't require that to take place. But those images will be acquired tomorrow. Downlinked over the next day or so, and obviously we'll be analyzing those intently. Remind me what the second part of your question was?
Yeah, just how precise is this moment of inertia measurement going to be in terms of estimating how much mass, how much sample you collected?
Thank you. So the mission requirement is to bring back 60 grams of regolith. And we have done a lot of work with this team to determine what the precision on that measurement is. And in fact, we rehearsed it during the checkpoint rehearsal and the match point rehearsal. Right now, we're carrying a 3 sigma uncertainty of about 20 grams on that measurement. So we've actually worked through this with our stakeholders at NASA headquarters, and 80 grams is kind of the magic number. If we see SMM coming in at 80 grams or higher, we have a 90% confidence of having collected 60 grams of regolith. So that's a key number that I'm looking for. If it's below that, it's a conversation that we have with the team, with NASA headquarters, Dr. Zurbuchen, to decide what do we think the best path forward is. But 20 gram 3 sigma is the number that we have agreed to with the agency.
Thank you. Operator, next question.
Craig Smith of KGUN Huskin, your line is open.
Thank you. A question for Dante. How is it decided just which organizations get which share of the collected material? What share do you expect University of Arizona to get? And please give us an idea of, I guess, the researchers who are lined up to get a look at that material.
Thanks, Craig. Great to hear from you. So first, the sample belongs to NASA and really to the American taxpayers. So the only transfer of sample that's been authorized is that 4% goes to the Canadian Space Agency. That's by mass. And then 0.5% goes to the Japanese Space Agency to reciprocate for their contributions to the success of this mission. The science team, which is what I lead, will be allocated 25% of the return mass and also 25% of the contact pads for our scientific analysis. But in all cases, that material still belongs to the agency and is under the control of NASA. And it's allocated to me and to the science team through what's called a loan agreement. But all that aside, we're basically planning right now on analyzing 25% of the return mass. And a lot of my activity lately has been in writing my sample analysis plan. And this has been really exciting to get to this stage in the program where we can lay out in detail the different analysts that will be looking at the material. Of course, the University of Arizona will be a central organization in the analysis of the return material. We've got new laboratories that we've installed over the last couple of years, a new instrument being developed right now that we're really looking forward to analyzing that material with. But the science team really spans the entire globe. We've got key organizations in the United States like NASA's Goddard Space Flight Center, Johnson Space Center that are going to play central roles in the sample analysis program. And then we've got team members in Canada, in Japan, and Australia, throughout Europe that are going to be involved in the program as well. And we'll be able to talk about that and roll that plan out over the next year or so as we finalize the details on that. But I can tell you, based on what I've seen today, we're looking at hopefully a lot of material and a lot of great science coming out of the sample analysis phase of OSIRIS-REx.
Great.
Great. Thank you. Congratulations.
Operator, next question.
Leo Enright of Irish TV, your line is open.
Thanks very much for doing this, and congratulations. A couple of questions. One for Rich Burns. You mentioned the possibility of maybe less of a sample than you had hoped for. Now, I realize this is unlikely, but if you found that you had less of a sample than you expected, is there a plan B? Can you go back, or is that it? And also for Dr. Loretta, can you talk a little bit about the rocks that we saw? You mentioned that the rocks seem to fragment very easily. What can you say about the nature of these rocks, and whether, for instance, if I picked one up, would I be able to crumble it in my fingers?
Thanks very much for that question. It's a great one. If we for some reason decided not to stow this sample, if we determined the mass was not sufficient, that we wanted to go back, we can in fact go back. We have 3 nitrogen bottles, which allows us to touch the surface 3 times. Of course, we've disturbed, as you saw in the animation, or not the animation, but the images that Dante showed, we've disturbed the surface of Nightingale in a radical way. So we won't be going back to Nightingale, at least for our second attempt. We would go to our backup site, which is called Osprey, which is a near equatorial site, and we're prepared to do that in the mid-January timeframe. I'll turn it over to Dante to answer the second question.
Yeah, the rocks on the asteroid surface have turned out to be fascinating scientifically, and the team has done an amazing job processing all of the remote sensing data that we've acquired starting in late 2018 and throughout 2019. I can answer the question that, first of all, the surface seems to be dominated by 2 distinct rock types. We see a very dark, kind of hummocky rock, which looks like the one that we crushed underneath it. And from recent analysis using the thermal data, how the rock heats up and cools off, we actually inferred that these rocks might be very weak compared to what we're used to dealing with here on Earth. And most exciting, I think, for me as a sample scientist, very weak compared to the meteorites that are currently in our collections here on Earth. So I think what we've seen is that our meteorites are possibly a biased sample, that they're only the most sturdy and strong material that survives passage through the Earth's atmosphere. And it looks like the material that dominates the surface of Bennu might be much more fragile and friable. And with this interaction of TAGSAM with the asteroid surface, that seems to be playing out. I can tell you the science team is already excited about the possibility of getting a direct strength measurement through detailed analysis of this image sequence, especially these two images right before and right after contact. The second kind of rock that we've seen on Bennu is a little brighter. It tends to be shot through with bright white veins or white inclusions that we've identified as a mineral carbonate. This is a mineral people are probably familiar with. It forms a kind of white crud around your faucets and sinks if you live in an area with hard water. It's basically an evaporite, and those rocks seem to be a little stronger, probably because of that material that has cemented them together. We do see maybe some hints that there was some of that brighter material, smaller fragments of it, underneath the TAGSAM head, but the team is going in for detailed analysis to determine if that's in fact the case. And then I'll just add, mineralogically, we've done a pretty good job understanding what these rocks are made out of. They're definitely dominated by hydrated minerals, that is, clays that have water contained in their crystal structure. That's very exciting scientifically. We've also seen an iron oxide called magnetite, abundant organic material, particularly carbon-hydrogen bonded material, which is really what this mission is all about, bringing back home, and then that carbonate material that I mentioned earlier.
Thank you. Operator, next question.
Nova PBS, your line is open.
Hi, everyone. Firstly, congratulations. This is just super exciting, and I know that we're all, to use your point earlier, over the asteroid for all of you guys. And if I'm wondering, from the images that you have currently, I know during Monday's press conferences there was a lot of conversation about diversity in regard to the size of the sample pieces as well as the material and everything. So is there any clue from the images that you have currently that we have a good diversity of really small pieces and maybe pieces closer to that 2-centimeter mark and maybe of different types of material as well? I guess that's for Dante or really anyone who can answer.
Yeah, I'll take that. I can say just within the past hour or so, I got the analysis from my image processing team about the exact location where we think the TAGSAM head made contact. So I haven't had time to process that information. I know that team is busy analyzing that. But from that quick look assessment, it does appear that we made contact with an area that had already been mapped out and verified to contain abundant sampleable material. Rich mentioned the imaging resolution during the Recon C characterization of Nightingale, where we got down to that 4 millimeter per pixel scale. So that this region does look really sampleable, lots of small particles, and then the fact that the material just crushed underneath the TAGSAM is just going to add more smaller particles for us to collect. But I don't want to answer the question just yet about the diversity of the rock types there, because the team is still processing that right up to the beginning of this media briefing.
Operator, next question.
Thank you. Let's see. And Ryan of Arizona Republic, your line is open.
Thank you. I wondered if you could explain a little bit more about how you will measure how much sample you've collected besides the possibility of images.
Yeah, so we've got a sample mass measurement activity. So we've been practicing this, as I think Dante or Rich mentioned, around our checkpoint and our match point burns, or activities where we can extend the arm and rotate the spacecraft, and we can measure the moment of inertia. And by doing that before tag and doing that same activity after tag, we can take the difference in those measurements to estimate the mass. So we did perform our pre-tag sample mass measurement activity about 10 days ago, and we'll do our post-tag one this Saturday, and we'll be able to take those two measurements and look at the difference of them to get that estimate of how much mass we believe is inside of the tag SAM head.
Operator, next question.
Thank you. Chuck Field of Your Space Journey, your line is open.
I thank you, everyone, for taking my call, and just congratulations to the entire team. I'm just wondering, what are the reasons for waiting until January for a second collection attempt? And if a third attempt is required, have you determined when will that take place and at which site?
So, yeah, great question. The reason that we would do a second attempt at Osprey in January, as you saw, we're backing away from the asteroid right now. And I mentioned that we'd be about 80 kilometers when we make a maneuver to arrest that drift away on Friday. That will put us on a trajectory that goes to a waypoint where we can re-enter orbit. You see the orbit in that animation that was just shown is a tenuous trick to get into. Bennu is only 500 meters in diameter, so its gravity field is extraordinarily weak. Just getting into orbit takes weeks of maneuvering to get there, and we also have to phase the orbit appropriately so we depart for the next sample collection attempt at the right latitude. All that takes weeks of planning and preparation. We also have to prepare the spacecraft to tag at a different site, which involves generating the spacecraft commands, testing them, and so forth. So that runs out the timeline to January. And then the third sample attempt would be to be determined date, most likely in March, when we'd be attempting a third attempt. But it largely depends on what happens at Osprey. If we were to go to Osprey in January and wave off, abort for some reason, and not touch the surface and not disturb Osprey, as we've seen the dramatic disturbance of Nightingale, we go back to Osprey. If we did disturb Osprey, that's a contingency that we would have to either perform more reconnaissance over one of the two, Nightingale or Osprey, or follow some other path. And the reason I'm saying that is we use optical navigation to get down to the surface. So much as you're driving to some location in your local town and you know where you are, where a gas station is or a supermarket, the spacecraft knows where it is by features on the surface. So groups of rocks that cast shadows or just clusters of rocks that have distinctive features are recognized by the spacecraft in its imagery as it descends, and it knows where to go. It knows to take the right turn at the supermarket to get to the center of the site. So once we disturb all those features, that means we're going to need to take more images and build a new set of feature catalogs to teach the spacecraft where the grocery store is.
All right. Thank you, Rich. Operator, next question, please.
Joshua Ortega of Contact News, your line is open.
Thank you for having me, and congratulations to everybody involved in this mission. What was one of the biggest discoveries that you made in making contact with the asteroid Bennu that you didn't expect? And my second question is, what is the future applicability for future projects with some of the technology utilized on the spacecraft?
I guess I'll take the discovery question. I could say we've had the data down for just a little over 13 hours, so the discoveries are still to come. What I was looking at this morning, 2 o'clock here, Denver time, after being up through a very exciting event, was how does it look in terms of getting the sample? So the science is something that we're going to think of down the road a little bit, but I can tell you that I was hopeful that the surface was going to be soft and crushable, and that was confirmed by our contact with the tag SAM and analysis of the images that we've seen here so far. So that is really good news. So I'm pretty focused on sampling success right now. I will tell you the science team is busy in a couple of different areas. They are working through a detailed analysis of this entire image sequence, along with additional data from the spacecraft guidance, navigation, and control team about exactly what happened when the spacecraft was in contact for those 6 seconds. That'll tell us a lot about TAGSAM performance, and there's also follow-on science that we'll be able to do with that information. But right now, I would say the big discovery is that it looked really sampleable, that the TAGSAM head pushed into the surface, and that it was in a very good position when that gas fired to collect a lot of material. So we still have all the confirmation activities that Sandy walked us through earlier in the briefing to verify all of that. But the trend right now is that we have sample and that we were successful here based on analysis of this image, this set of images.
Yeah, I'd love to speak to the second part of that question if possible. Yeah, so the question was what technologies on board the spacecraft can enable future missions, and I think one of the most amazing technologies is the optical navigation system I talked about, what we call natural feature tracking. And it has actually an amazing story. The spacecraft was originally designed to use a LiDAR to measure the altitude to the surface as its primary sensor to do the navigation to the surface. But natural feature tracking or optical navigation was added around the critical design review time period in order to have a backup solution. And as I mentioned, what it does is recognize features on the surface of the asteroid and then update its own sense of its position so it knows where to go in the future. Now, this technology being added late in the game was done by our colleagues at Lockheed Martin, and it was an amazing accomplishment, amazing engineering accomplishment, and one of the most amazing performances of the system yesterday was just how well that system performed relative to our simulations of it. Optical navigation systems are notorious for not performing as expected, and this one performed exactly as expected and allowed us to hit that center of the target within a meter. So our colleagues at Lockheed Martin deserve a lot of credit for that. And how that gets applied in the future is it will allow for autonomous navigation for other deep space missions to small bodies or not, for landing or navigation around hazardous or non-hazardous environments. So I don't know if, Sandy, do you want to follow on to that at all?
Yeah, definitely. I would for sure have pointed out natural feature tracking as a capability that I can see can be useful in the future. I'll also point out that TAGSAM is new technology flying on board the spacecraft, and you can see that going forward for future sample collection, sample return missions.
And one more quick question for the NASA representatives. What is this? Is this the first time working with the University of Arizona, and what does this say about the school and future projects with the school as well?
It's Thomas here, head of science. No, this is not the first time. I think of the University of Arizona, and it's kind of partner university up the street, so to say, Arizona State, to really be kind of meccas of planetary science and exploration. The University of Arizona has had the principal investigator of multiple missions and continues to compete very well in many different areas. And really, especially in planetary science, the University of Arizona is one of the top leaders in the whole country.
What did you say about Arizona State University as well?
Arizona State University, frankly, is if you just lined up kind of the top universities in planetary science, both the University of Arizona and the Arizona State rank in the top part of such a ranking list. So Arizona State also, at this moment in time, for example, has a principal investigator of a discovery mission called Psyche. There's instruments that are being built there for other missions. So also Arizona State is a really critical partner for NASA in this and also other disciplines.
Thank you. Thank you very much for your time.
Thank you. Operator, next question.
Mark said, Magazine. Your line is open.
Hi, thanks very much for taking my question, and congratulations to everyone. I just had a couple of questions on the series of images that was released and the really impressive rubble cloud that this kicked up. Just wondering if you're able to glean anything scientifically about the surface material from the dynamics of that cloud and the rocks and particles that make it up. And then obviously you expect it to make a mess, but what kind of safeguards or system checks are in place to make sure that the craft wasn't damaged by that? And then finally, I was just curious, what is the time step between those images? So what's the effective frame rate of that video?
So I'll answer the imaging questions, and I'll hand it over to Sandy for the safety assessment of the spacecraft. So right to your final question, those images are about 1.25 seconds apart. So the first version I showed, which was the larger image sequence, was sped up by quite a bit relative to that frame rate. In terms of the debris cloud, absolutely. It actually is kind of impressive. The fragments that we see flying around, there's some pretty large particles. One of the things the science team has already started doing is tracking the trajectories of the particles as we see them mobilizing across the images here. They're going by pretty fast right now, but obviously we're slowing those down, identifying individual particles. There's other images, too, that we collected with a different camera called the NavCam, the one that was used for the natural feature tracking. I was getting a quick look at those right before the media conference. Those are fresh off the spacecraft, so we're still processing those and analyzing those, and those will be released a little later on this week. But those give us a wider field of view as well, so we're kind of getting this great point of view of the SAMCAM contacting the asteroid surface and all the particle debris that we see. And then we have the NavCam 2, which is off-pointed a little bit in a wider field of view, so they're going to be a nice image pair. And I think the final thing to point out is that the initial ejection of particles actually comes from the TAGSAM gas as it was blown down through that sample collector head. But you got to remember, we were only in contact with that asteroid for 6 seconds. After that point, the backaway thrusters fired, and those kicked up a second set of cloud and debris. So we're still disentangling that whole history. What was liberated by TAGSAM, what was kicked up by the backaway thrusters, and the NavCam images are pretty fresh right now on the ground, so we got a quick look at those. They're very impressive, just to get everybody excited, but we're not ready to release those because we haven't really had a chance to process them ourselves quite yet. And I'll hand it over to Sandy about the safety assessment.
Yeah, so the spacecraft was designed for this. We knew when we made contact that we were going to stir up a lot of regolith. There was a large backscatter study done during development to make sure that we would keep the spacecraft safe. Now, just by monitoring this spacecraft over the last, close to 24 hours now, we've been able to see a number of components, and we're trending, as our subsystems do throughout, making sure that things are going as planned. And they're not seeing any changes in their measurements. Now on early next week, I believe Monday, we'll be doing a spacecraft checkout where we'll get a chance to take some star camera images on both of our primary tracker and our redundant tracker, and we'll get to do some other engineering activities to better inform us if we've had any sort of degradation on the vehicle.
Great. Next question.
Lisa Grossman of Science News, your line is open.
Hi, thanks for taking my question. I was wondering if you knew if any of the regolith that got disturbed, any of the stuff that got tossed up into space around Bennu would end up at Earth, and if maybe you just created a new meteor shower.
Hi, Lisa. I'll answer that one. I think you read my mind. I certainly have been thinking about that. We have thought about that, as I mentioned yesterday, and we've talked about for quite a while on the mission. Bennu is already kicking particles off the surface, and one of the things that we are doing is monitoring for a meteor shower, which would occur in the southern hemisphere in the third week of September, which is when Bennu's orbit crosses that of the Earth's orbit. We actually had data that we just recently received from that meteor campaign, and we're still processing that to see there's maybe a small signal, but maybe not, of natural Bennu meteors. So that idea is already in place. That kind of study is something that we're already pursuing. So I'm going to go back to that team that's responsible for that investigation with your exact question. I haven't had a chance to ask them that. I didn't dare to hope that we would kick up as much debris as we're seeing here. So I'm not sure, but it's definitely a question I've asked myself, and we've got team members who are thinking about that based on Bennu's natural particle ejection events. So it is a natural line of inquiry, but we just need some time to push through this very exciting operational phase of the program and start to think about some of the long-term science implications. We do have a phenomenal scientific data set. TAG was a great science experiment, and so there's going to be a lot of work that comes out of it, but we need time to get the data down, to get it calibrated, processed, and to just spend some time thinking about it without all these critical operational decisions in front of us like we have over the next couple of weeks.
Okay. Next question, operator.
Stephen Clark, flight now. Your line is open.
Hi, thanks for taking another question. Dante, the material that we see in the imagery that was disturbed and kicked up with the TAG event, any estimate yet on how big some of those particles might be? They look kind of small, but it's hard to tell from the scale. And also, if you did collect the required sample of 60 plus grams, what is the flight plan for OSIRIS-REx over the next few months, and do you have a date for departure for Earth? Thanks.
Yeah, great question, Stephen. Can we bring up the third set of images that I was showing here where we were looking at some of the debris and maybe slow it down a little bit? I know we talked about that. So just remember, for scale, we're looking at this TAG SAM head, which is 30 centimeters in diameter. This is the full-scale model here. So you can get a sense, you know, the spacecraft's only a little over 2 meters away, or 6 feet away, so not much farther than my span here. So you can actually kind of estimate the particles. You know, so we're looking at things, you know, that's probably on the order of centimeters to several centimeters. And then we've got this guy here. This is a pretty amazing looking particle. So if it was to scale with the TAG SAM head, it would be on the order of 15 centimeters. It's probably a little closer in our field of view, so it's going to be a little smaller than that. But this is the biggest one that I've seen so far in my assessment of the data. Of course, the team is going through with much more careful analysis. But I'm guessing this is multiple centimeters, maybe up to 10 centimeters across here. And this guy kind of comes shooting off from the right side of the field of view and moves over off the image to the left. So there's certainly a lot of work to do to really get a sense of how far away, what's the depth of field of view of the image that we're seeing here, and to do some real precise measurements of the sizes of these particles. But this one alone shows me we picked up some things that are pretty big. But for the most part, we're looking at centimeter, sub-centimeter scale particles just from a quick look assessment. But there's a lot more detailed analysis to go. This is all preliminary, and the image processing team at the University of Arizona is busy, as we speak, answering that exact question right now. And then I think over to Rich for the departure date and the return cruise.
Right, so if we stow the sample, we'll be doing so in the first week of November. And we'll follow, continue to drift away from the asteroid after we make that maneuver on Friday, rather than attempting to reinsert into orbit. Our departure window opens in March. That's when the orbital mechanics say it's fuel efficient to get back to Earth, and our designated date in September of 2023. We'll depart the asteroid in early March at the opening of that window.
Okay, we have time for one final question. Operator, please patch it through. Operator, do we have another question?
I do apologize for that technical issue. Michael Greshko with National Geographic, your line is now open.
Hi, thank you so much, and congratulations to the team. I had a question about sort of the aftermath of this tag. What are the plans, if any, to do any sort of remote sensing on Nightingale site to sort of see the hole you all left? And then more generally for the team itself, I mean, this moment has sort of captured the world's attention. Anything at this time you want to say to people around the world who are watching this and sort of taking this in along with you?
Sure. I'll answer that. It's a tough question, Michael, because there was a lot of interest from the science team on more data, more characterization of Bennu after the sampling attempt. But, you know, we gathered together as a management team and we evaluated that exact question very thoroughly. And we agreed unanimously that this mission is about safe return of this sample. And we do not want to do anything to put that sample at risk. So the plan right now is we're going to go through these verification activities on the flight system. We're going to check out the state of the vehicle. If everything looks positive and we meet with Thomas on October 30th and make that decision to stow, that is the end of the science campaign at Bennu. We are then solely focused on the return cruise. And quite honestly, the real scientific payoff, which this mission is designed to do, is that sample return and the sample science. And we'll be putting our focus and our resources into that. It wasn't an easy decision, guarantee you. It was tough, especially the scientist in me always keeps asking those questions, but it's the right decision to maintain that focus on the level 1 requirement. Because I can tell you, right before we kicked off the tag activity, I went through all of our publications and all of our data, and I mapped them to the level 1 requirements of the mission, which is what I agreed to with Thomas and Lori that this program would deliver. And we have met, and in most cases vastly exceeded, all of the science requirements associated with the remote sensing campaign of Bennu. So all we have left to do to deliver on our promise to the agency is get that sample safely back to the Earth, get it into our laboratories, and answer the fundamental questions about the formation of our solar system and why Earth is a habitable world. And then you gave me a chance to promote a message, and I'll just say, OSIRIS-REx, in my opinion, is the culmination of human activity as a species. We built this mission for peaceful purposes, out of curiosity and our desire for knowledge. It's a team that comes from a variety of backgrounds and viewpoints, but none of that matters because we work together, united in a common vision and a common goal. And when we do that, we achieve amazing things. And so I told the team, I know we focus so much on the details and the technical implementation of this program, but we serve as a model for what we can do as human beings when we unite in a common vision. When we're united, we're strong, and when we're divided, we're weak. And so I hope that message of unity and common purpose, and that we're all in this together, right? We've got this precious planet Earth that we're the stewards of, that we're responsible for. And when we come together and unite, we achieve amazing things.
Could I follow on to that as well, please? Yeah, I think one additional thing to add on to that, beautifully put, words from Dante, is, we're hoping to serve for an inspiration for future scientists and engineers. This mission is as much fun as you can have and get paid to do, right? So I had one of our instrument scientists was examining the images from our navigation cameras as it came down this morning. He said, his subject line, his email he sent to me, the image was, "This is so cool," right? And it is. And what he finished his email with was, "I love this job." So we're hoping that, there's 5, 6, 10-year-olds out there that get inspired by this mission, the amazing achievements of this mission, and it's the people, the engineers and the scientists on this mission that made it happen. So we need our future generations to be inspired by this, and that's what we're hoping to do. And I think the other thing is, Dante mentioned the sample allocation. A large fraction of the sample is going to be reserved for study of future generations. So we're hoping that future sample scientists are inspired by this. And, kids at home today could be the ones studying this sample in 10 or 20 or 30 years and make new discoveries that aren't even possible with today's technology. So, thank you.
Well, that was a great way to wrap the show up. And as your engineer said, the images, they are cool. So before we close, we'd just like to invite everyone to tune in to the NASA Science Live that's going to follow this press briefing at 6:15. So go on over to nasa.gov/OSIRIS-REx, where you'll see a presentation from various OSIRIS-REx scientists. They'll talk a little bit more about the images and about the overall OSIRIS-REx mission. I just want to say congratulations to the team. Go OSIRIS-REx. And thank you for tuning in.